video on type 1 and type 2 errors in hypothesis testing. After watching this video, you should be able to define a type 1 and type 2 error in hypothesis testing, explain what a type 1 or type 2 error would look like in the context of a specific example, define alpha and beta, state the relationship between alpha and beta, and state how to decrease both alpha and beta at the same time. Hypothesis testing is not a perfect process. In an ideal world, only guilty people would be prosecuted and only innocent people would be acquitted. In real life, however, we know that many times people are convicted of a crime they did not commit, while other people who did commit crimes are not convicted of them. In hypothesis testing, these errors are called type 1 and type 2 errors. A type 1 error occurs when an innocent person is convicted of a crime. A type 2 error occurs when a guilty person is not convicted. The four possible outcomes of hypothesis testing are often organized in the following table. Notice that the columns represent the reality of the situation. So in this example, the null hypothesis is true in reality, which would mean that the person is innocent. If the person is innocent and we retain the null, which means that we say that they're not guilty, everything is great. Everything is as it should be because the person was not convicted and the person is actually innocent. Likewise, if in reality the person is guilty, in other words, the null hypothesis is false, and we declare the person guilty, meaning we reject the null, then everything is as it should be. The person who committed the crime is, as they say, doing the time. Problems occur, however, when we have a person who is innocent or a null hypothesis that is true, and we mistakenly reject the null or convict the person of the crime. Again, this is called a type 1 error or a false positive. The innocent person is being convicted of a crime. Likewise, there's a problem if a person is actually guilty or the null hypothesis is false, but we mistakenly say that the person is not guilty, or we mistakenly retain the null. This is called a type 2 error or a false negative. Again, we are saying that the person is innocent when in fact they are guilty. Let's practice identifying type 1 and type 2 errors in the following example. Suppose a person is driving erratically or speeding late at night and is pulled over and accused of driving under the influence of alcohol. What would a type 1 error look like in this case? What would a type 2 error look like, and which one do you think is worse? Pause this video, write down your answers based on the previous slide, and then unpause the video to see if you are correct. So remember, a type 1 error is a false positive. That means that the person is sober, but is thought to be under the influence of alcohol and therefore is convicted of a DUI, driving under the influence. Well, what are the outcomes of a false positive in this example? It can have serious adverse consequences for the person who is wrongly convicted. A DUI is very costly and it goes on your permanent record. You might have to have a breathalyzer installed in your car, and you might have to take some classes. And again, all of those you'd have to pay for out of pocket. So clearly, this is not a desirable outcome for the person who is being wrongly convicted. Let's look at a type 2 error or a false negative. A type 2 error or false negative means that the person was in fact under the influence of alcohol, but for some reason was released or let go. Well, what does this mean? That means that the person is allowed to get back into his or her car and continue to drive. While the individual might be relieved that they don't have a DUI on their record, the false negative can have serious consequences not only for this individual, who is him or herself at risk, but also for the innocent drivers on the road. As far as which one is worse, I'll let you decide. I would argue myself personally that a DUI, a false positive, is worse for the individual who has to suffer the consequences of having a DUI on his or her record and paying all this money, but for society in general and for innocent bystanders, a type 2 error is infinitely worse. Let's look at another example. Suppose a company implements a program to increase worker safety on the job. They hypothesize that this program is effective in reducing the number of accidents on the job. What would a type 1 error look like in this situation? What would a type 2 error look like, and which, in your opinion, is worse? Remember, a type 1 error is a false positive. That means the company believes the program was effective in reducing the number of accidents on the job, but in fact it was not. What does this mean? Well, if the company believes they solved the problem, they might not investigate the issue anymore. They might not apply any more measures towards making the work site safer. This is not good for workers who may be unsafe on the job. What about a type 2 error? Remember, a type 2 error is a false negative. That means the program was effective in increasing worker safety, but for some reason the company concludes that it was not effective. If the company thinks the program was ineffective, they may reverse the safety measures they implemented that actually worked. They might also try new or different safety measures. Either way, this will be costly for the company since they will have to spend more money unnecessarily because they already found an effective way of making the workplace safer, but they don't know that. Which one is worse? It's really up to you to decide. What is the probability of making a type 1 or type 2 error? In the previous chapter, when we constructed confidence intervals, we found out that we can never know for 100% certain that the confidence interval contains the true population parameter we are trying to capture. Similarly, in hypothesis testing, we can never know for sure that the decision we make in the hypothesis test is the correct decision. In a confidence interval, we have a certain level of confidence, usually 90, 95, or 99%, that the interval is capturing the population parameter. Likewise, in hypothesis testing, we have a certain probability of making a type 1 error. This probability is referred to as alpha. Similarly, there is a certain probability of making a type 2 error, and this is referred to as beta. The level of significance alpha is the probability of making a type 1 error. The relationship between alpha and beta. Unfortunately, alpha and beta are inversely proportional. This means that as alpha, or the probability of making a type 1 error decreases, the probability of making a type 2 error increases. Obviously, neither type 1 or type 2 error is desirable, as we've seen in the previous examples. We'd really like to decrease both the probability of a type 1 error and a type 2 error. But how can we do this if, as we decrease one, the other one goes up, and so on and so forth? Well, the easiest way to decrease both at the same time is to simply increase the sample size n that we are using. Having watched this video, you should now be able to define a type 1 and type 2 error in hypothesis testing. Explain what a type 1 or type 2 error would look like in the context of a specific example. Define alpha and beta. State the relationship between alpha and beta, and state how to decrease both alpha and beta at the same time.